As stated in Chapter 1, Muscle Physiology of the NSCA CSCS, it is the arrangements of the myosin and the actin filaments in the Z lines of the sarcomeres that give skeletal muscle its alternating dark and light pattern, its striated appearance under magnification. The dark A band corresponds with the alignment of the myosin filaments, where the light I band corresponds with the areas of the two adjacent sarcomeres that contain the actin filaments. The Z line is in the middle of the I band and appears as a thin dark line running longitudinally through the I band. The H zone is the area in the center of the sarcomere where only myosin filaments are present. During muscle contraction, the H zone decreases as the actin slides over the myosin towards the center of the sarcomere. The I band also decreases as the Z lines are pulled towards the center of the sarcomere. Parallel to and the surrounding each myofibril is an intricate system of tubules called the sarcoplasmic reticulum that terminates as vesicles in the vicinity of the Z lines. Calcium ions are stored in these vesicles. The regulation of calcium controls muscular contraction. T tubules, short for transverse tubules, are run perpendicular to the sarcoplasmic reticulum and terminate in the vicinity of the Z lines between the two vesicles. The resting phase of the sliding filament theory of muscular contraction. Under normal resting conditions, little calcium is present in the myofibril. Most of it is stored in the sarcoplasmic reticulum, so very few of the myosin cross bridges are bound to the actin. No tension is developed in the muscle, so the muscle is said to be at rest. The excitation contraction coupling phase. Before myosin cross bridges can flex, they must first attach to the actin filaments. When the sarcoplasmic reticulum is stimulated to release calcium ions, the calcium binds with the troponin, a protein situated at regular intervals along the actin filament that has a high affinity for calcium ions. This causes a shift to occur in another protein molecule, tropomyosin, which runs along the length of the actin filament in the groove of the double helix. The myosin cross-bridge head now attaches much more rapidly to the actin filament, allowing cross-bridge flexion to occur. The contraction phase. The energy for cross-bridge flexion comes from the hydrolysis of adenosine triphosphate to adenosine diphosphate and phosphate, a reaction catalyzed by the enzyme myosin ATPase. Another molecule of ATP must replace the ATP of the myosin cross-bridge head before the head can detach from the active actin site and recock. This allows the contraction process to be continued if calcium is available to bind to the troponin, or relaxation to occur if calcium is not available. It must be noted that the calcium plays a role in regulating a large number of events in skeletal muscle besides the contraction. These include glycolytic, oxidative metabolism, as well as protein synthesis and degradation.